Hello everyone, and today we're going to see about another problem on mesh analysis. So this is a problem. And you want to find out the current passing through the um, this 15 ohms resistance. So this 15 ohm resistance and the current flowing through the 5 ohm resistance, and there's a current flowing through the another 5 ohm resistance. So there are two power sources are given, and each of it is a 100 voltage, and there are 1, 2, 3, 4, 5. There are 5 resistance are given, and let us see how many loops are being there. And there are one. This is one loop, and this is the second loop, and this is the third loop. So by default, we can take all the loops, the current passing through the individual loops in the clockwise direction. So let us name each and every current. So this is the current I1, and this is the current I2, and this is the current I3. So by this is by default, we are taking the current as I1 and I2, I3, and here all the currents are in clockwise direction. So today we're going to solve this mesh analysis by using the Cramer's rule method. So it is a matrix kind of a formation. So you have to frame a matrix of the basic of R I, that is a current matrix, is equal to the voltage matrix. It is nothing but the basics of the Ohm's law. So once you have formed this matrix, and you can if you solve this algebraic equation, you can directly find out the what is the current current flowing through the what are the these three unknown currents can be find it out. So let us see what is in the R matrix. The R matrix composes of R11, R12, and R13. Since there are three loops are there, and we are going to take over the R11, R12, and R13. So as you know what it is for the second row, R21, R22, R23, and this is R31, R32, and R33. So this is our resistance matrix, and we need to find and then there is a current matrix is there. Uh, we know that there are three currents are there: I1, I2, and I3 is equal to V1, V2, and V3. So these are the three voltage levels. So we need to find out the R11, what is R12, and R13. So the R11 is nothing but the total number of resistance value that is available inside this first loop. The total number of resistance that is available inside this first loop. So this is our first resistance 15 ohm, and this is second resistance 20 ohm. So when you add 15 plus 20, you'll be getting 35. So next one is the R22. So we are going to take over the diagonal matrix first, and then we can go with the um, R12 and R21. So that's kind of matrix can be looked over. The value for this particular matrix can be looked over. So R22 is the sum of the resistance that is being available. For example, 20 plus 5 plus 30. So it will be giving us 55. So next one is the R33. So R333 is the sum of the resistance in the third loop. 30 plus 5, that's 35. It's 35. So next one is a R12. Um, it is the resistance that is being linked between the first loop and the second loop. So let us see what is the resistance that is being linked with the first loop and second loop. It is a 20. So let us find the sign for this 20 loop. So as if both the currents are in the same direction, or both the current in same direction, we have to take it over as positive sign. If it is in opposite direction, we have to take it as a negative sign. So this is the prime rule for solving a mesh analysis in this method. So let us see, this is the I1 that is flowing through here, that is I1 is flowing through here, and a clockwise direction of the I2 is from here. So both the current are in opposite direction. So we are taking as a 20 as a minus 20, and it will be the same value for R21 also. So next one is a R 2, 3. So R13. Let us see what is R13. That is the resistance that is being linked between the first loop and the third loop. So as you see here, there is no resistance is being linked between the first loop and the third loop. We can consider this as a zero value. So in the second row, we have to go for 2, 1. I'll already find it out. We have 2, 2 is already being found out, and 2, 3. So we have to look over what is the through 3. That is the resistance that is being linked between the second loop and the third loop. It is nothing but it's 30. So we have to take it as a 30. We have to take it over, and we also look over the signing convention. So that is the current passing through is I2 is from the up to down, and I3 is from bottom to top. So definitely it is also a negative sign. So next one is the R31. So the R31 is directly third loop that is being connected to the first loop. We can take it over as 0. This is the same as R13, and R31 is 0. So next one is the R32. That is the third loop that is being linked with the second loop. So it's same as a R23 is equal to R32. So that's same 30. So now we can get over the equation for that is the matrix for this particular resistance matrix. So let us place all the value. R11 is nothing but a R11 is the 35. R1 R22 is a 55, and R333 is a 35, and R12 is minus 20, and R13 is a 0. So next one is R21. The R21 is a same as a minus 20, and R23 is a minus 30. 32 will be the same as 30, and R13 will be, that is R31 will be 0. So the current is still it is an unknown one, I1, I2, and I3. So let us see the voltage that is being linked with each and every loop. So since the current direction is from bottom to top, that is from minus to plus, so definitely it is going to be a sourcing region. So definitely the the voltage will be having the positive nomenclature. That is, we have to write it as a positive 100. And the next loop is a just 0. The third loop, that is from positive to negative, there is a fall in the voltage level. Now we have to write it as a minus 100. So let us derive the equation for this each and every loop. So it is nothing but a 35 I1 minus 20 I2, zeros we are neglecting the I3, and it is equal to 100, and minus 20 I1 plus 55 I2, and minus 30 I3 is equal to 0. So minus 30 I2 plus 35 I3 is equal to minus 100. So these are the three different loop equation, and once you solve this loop equation, you will be getting the value as I don't want to go for the inner steps of the solving the algebraic equation, as you all very aware about the solving the algebraic equation as you studying from childhood days, and also you can do it by calculator also, scientific calculator. That is the I1 value will be 1.9 ampere, and I2 will be around 1.6 ampere, and I3 will be like 4.22 ampere. So these are the final current value, loop current value for this problem. So thank you all. I hope you all understood. So if you have any doubts, you can message me, or you can look back the video again and again, so that you will be clarified with the doubts. I'll be summarizing what we have done so far. So we need to have the current direction, and by default we'll be taking as a clockwise direction. And so you have to go for the resistance into current is equal to voltage format for solving the mesh analysis, and R11 and R12 and R13. The R11 is the total number of resistance available in first loop, and R12 is that is a linked resistance between the first loop and the second loop, and R13 is a linked resistance between the first loop and the third loop, and R21 is the linked resistance between the second loop and the first loop, and R22 is the total number of the resistance that is being available in the second loop, and R23 is a link between the second loop and the third loop. So R31 is nothing but a R31 is the link between the linked resistance between the third loop and the first loop, and R32 is the link between the third loop and second loop, and R33 is the total number of the resistance that is being available. So once you have find out these resistance value, and you can derive the algebraic equation for each and every loop. So once you have arrived with the algebraic equation, you can solve it by to find the unknown current value for each and individual loops. So that's all for today, and we'll be solving certain problems in the next lecture. Thank you all.